Hello, welcome to my channel. In the last video, we have studied about the homogeneity of the dimensional equation, which is one of the application of the dimensional equation. In today's video, we are going to study about second application of dimensional equation. In this video, the application of dimensional equation is that we can able to derive the equation without being able to go into deep mathematics by just dimensional equations. Like if let's let's write the topic: deducing relation among physical quantities. Let's consider an example so that it can be easily understood. Let's consider a bob which is tied to a string of length L and mass M. The bob is of mass M and the wire is of length L. Now it is led to oscillate, and it is oscillating with the time period of t. So we have to deduce the relation between the time period with mass, length, and g, acceleration due to gravity. Obviously we don't know how they are dependent before before knowing the formula. We cannot say how they are dependent, so we can write t is directly proportional to m, l, and g, and when we remove we get proportionality constant, that is k. Now we don't know the value of k, so by this, here k is a proportionality constant. Now we have to find the relation of how time is dependent on mass, length, and acceleration due to gravity. So let's convert all this into dimensional equation, such the dimension of t, dimension of k, l, g. Obviously the constant are neglected here as they have no dimensions of themselves. So t is time, k is neglected, m is m, l is l, g is acceleration. So acceleration at dimensions of lt minus 2. So let's write it down. Then m l2 t minus 2, then t. So before going to solve this, we have to consider we don't know how they are dependent. In this, if we take 1 we are actually saying that it is dependent directly proportional. So let's take a, b, c. So a, b, c are any integers, and we don't know how a, b, c are real numbers, and we don't know the value of a, b, c, which means we get a, b, c here too, and m power a, b power l power b, and lt minus 2 power c. So 2b t is equal to m power a, l power b plus c, and t power minus 2c, and t power is 1. Now we have to compare, and as we have to compare both side powers. We have to take m power 0, l power 0, which means there is it doesn't depend upon m and l in the left side, so we take 0 0. So compare the powers of the bases m, l, and t, so that we get. So for m, we obviously now we have to find the value of ABC. So on the both side we are gonna compare the value of bases of MLT, power of MLT. Then we get 0 is equal to a, and for L we get 0 is equal to b plus c, that is b is equal to minus c. For t we get 1 is equal to minus 2c, that is c is equal to minus half. So b is equal to plus half. So we have to substitute this in the equation. T is equal to k m power a, l power b and g power c. When we substitute it, we get k m power 0, l power half and g power minus half. When we simplify it, we get k root of l by g. So we can see here that time is independent of mass, but it is square root of L divided by G. So let's start doing some questions. Let's take up some questions. So we have the question that if the time period of vibration, that is t, is depends on the surface tension, that is S and R, and density. So we have to derive the expression for T. So first we start writing. So T is directly proportional to S power A, R power B and rho power C. So we don't know how they are dependent, so we are taking the real number A, B and C. Let's remove the proportional. We get K, S power A, R power B, rho power C. So time period. So let's start making this as dimensional. So taking the dimension, we get K, S power A, R power B, rho power C. So we get for time period it is T, and K is neglected as we are taking dimension. So S power A means so, and as S is surface tension, R is radius and rho is density. So surface tension dimension is surface tension formula is force per unit length. So that is mLt minus 2 divided by L, that is L cancel, mt minus 2, and R is length, so L, and rho is mass. We know that it is density means mass by volume, that is m L minus 3. So we can substitute it here. So T. So when we substitute it, the value of S, R and rho, we get this equation, and when we solve it, we get this. So continue. Let's continue solving it. So compare the powers of the bases. So for m bases we get 0 is equal to A plus C. For L we get 0 is equal to powers B minus 3C. For T it is 1 is equal to minus 2A. When we solve it, we get minus C, B is equal to 3C, A is equal to minus of. So we got the value of A. We can substitute it here, where we can get value of C, and we can substitute value of C here to get value of B, minus 3 by 2. So when we put the value of ABC in the equation, we get T is equal to K, S power minus half, R power 3 by 2 and rho power half, that is K R 3 by 2 rho by S. This is how time period depends on R, rho and S. So let's start doing our second question. So the question is given as the frequency of vibration of mass m, of spring constant k is given by the relation f is equal to c m power x k power y. So c is dimensionless constant, which means this. So we have to find x and y. So let's take the given equation m power x k power y. So here k is spring constant. Spring constant formula is f by x, which means dimension of this is ml t minus 2 and l, that is l cancel mt minus 2. So dimension of k is mt minus 2. So frequency is 1 by t. So dimension of frequency would be t minus 1, and m is mass, so m power x, k means spring constant, which you can substitute it here. So we get m power x plus y, t power minus 2y, t power minus 1, m power 0. As there is no L term, no need for taking L power 0. So power should be compared on both sides of same basis, that we get minus 1 is minus 2y, y is equal to half, and x is equal to minus y, that is x is equal to minus half. So we are given the third question as P here. P represent the pressure and represent radiation pressure, and C is the velocity of light, and S is the radiation energy striking per unit area. Radiation energy striking per unit area, and x comma y comma z are integers, non-zero integers, and such that p power x, s power y, and c power z is dimensionless. So we are given that we have to find value of x, y, and z such that the whole term should become dimensionless, that is p power x, x power y, c power z has no dimensions totally, not individually but totally. They shouldn't have any dimensions, which means we have to find x comma y for this equation. So let's start doing. So P is pressure. P pressure means 4 per unit area, that is mlt. Dimension of P would be ml minus 1 t minus 2, and S is the radiation energy striking per unit, which means work divided by area into it is small correction, radiation energy striking per unit area per second, so which means S. So dimension of S would be m l t minus 2 into L, force into displacement is work, and area L power 2, and second is time. So L squared cancel, and we get m t minus 3, and c is speed of light, which is speed, dimension of speed. So we can substitute it in the equation 1. We get ml minus 1 t minus 2 power x, and s is radiation energy per second per unit area, which is mt minus 3 power y. C is Lt minus 1 power z, which is equal to m power 0, L power 0, T power 0. So we would get m power x plus y and L power minus x minus plus z and T power minus 2x minus 3y minus z is equal to m power 0, L power 0, T power 0. Let's solve it. 0 is equal to x plus y, 0 is equal to minus x plus z, and 0 is equal to minus 2x minus 3y minus z. So let's solve this equation. These equations, so let's compare both sides. When we compare the both side of the equation, we get this. So let's start solving it. So let's start solving this equation. So y is equal to minus x and z is equal to x, and 2x plus 3y plus z is equal to 0. So substitute value of z and y in this equation. So 2x plus 3x 3 of minus x and plus z is equal, plus in place of z we get x is equal to 0. So solve this, which is 3x minus 3x is equal to 0. Here in this equation, as we are getting 0 is equal to 0, so we can see here that from y is equal to minus x, z is equal to x, for any value of x we don't get any one solution, but we get in many infinite solutions. Like for a given value of x, value of y will be minus x and the value of z will be x. So if we take x is equal to 1, we can check it out the equation. Y is equal to minus 1 and z is equal to 1. We can test this here. ml minus 1 t minus 2 1 m t minus 3 power minus 1 l t minus 1 power 1. So m plus 1 and minus 1, plus 1 and minus 1, l is equal to minus 1 and plus 1, t is equal to minus 2 plus 3 minus 1. So we are getting m power 0, l power 0, t power 0. So we get this value for all the values of x. So we don't get any particular solution, but we get many solutions here. So x is equal to, if we consider k, then y is equal to minus k and z is equal to k be any real number. So let's take up the next subtopic about limitation. Dimensional equation. So the first limitation of by deriving by this dimensional method is that it only work for product terms. For if ut plus half at square, it doesn't work for this, but it only work for the equation having only product. So for that, first one is product terms only. And the second one is, we cannot find the dimensional constant, the proportionality constant, we cannot find by this method. We have to find for another, we have to find by another method. K doesn't have any dimension, we cannot find K value by this method. So for the third and the last limitation of by solving this method is that if we have more equation than the, as we have only MLT, then we get only 3, we get only 3 equations. If the physical quantities, if the unknowns A, B, C, if it is more than 3, if it is 4, then we cannot find, we can just have to guess the value. If we have only 3 equations, then we should have less than or equal to less than 3 variables to be able to find the answer. If it is more than 3, we cannot able to find the solution. So thanks for watching.